Hello, ladies and gentlemen. Welcome to tonight's daily LeetCode challenge. We have question 752, open the lock. You have a lock in front of you with 4 circular wheels. Each wheel has 10 slots, 0 to 9. The wheels can rotate freely and wrap around. For example, we could turn 9 to 0 or 0 to 9. Each move consists of turning one wheel, one slot. The lock initially starts at 0, 0, 0. 0, a string representing the state of the 4 wheels. You're given a list of dead ends, meaning if the lock displays any of these codes, the wheels of the lock will stop turning and you will be unable to open it. Given a target representing the value of the wheels that will unlock the lock, return the minimum total number of turns required to open the lock, or -1 if it's impossible. So in order to solve the solution, we need to use a queue to simulate the moves consisting of turning one wheel, one slot, like the question says. So each move consists of turning one wheel, one slot. So we'll use a queue to do them in order, or to do them one move at a time. And each move, you can move one of the digits up or down described in this example. So we're going to use a queue to simulate these moves, and we will start the queue at 0, 0, 0, like the question says, and then we will grab all possible paths from this element in the queue. So we're gonna pop the next element off the queue, and we will grab all the possible paths from this element in the queue and extend them into the queue. And we will just do, and we will add one to the step metadata each iteration. So we're going to keep a metadata for each combo that we have in the queue, and it's just basically going to tell us how many steps it took us to get to this position. And we will have a set that will remember our visited combos, and for each element in the queue, we do our checks to see if it's target, if it's in dead ends, or if it's in dead ends. And then if the queue ends with no answer, we return -1. So the runtime of this problem is basically all the possible combinations that we can generate, right? The worst possible runtime we can have is visit all these possible combinations, which is to the 4th power. So 10,000 combinations. And so the runtime is O of 10,000. There's 10,000 combinations. The worst runtime is we visit every 10,000 combinations. Same with the space. Big O of 10,000. Okay, so yeah, let's start coding. So we need a check. So if (0, 0, 0) is in dead ends, then we return -1. So if we can't even start the combo at 0, 0, 0, 0, we will return -1. And let's set dead ends into a set. So our checks can be done in all of one time. And then Q equals DQ, or from the collections module, and while Q, let's add 0, 0, 0, 0 to Q. And it will be accompanied by 0 steps. So the combo 0, 0, 0, 0, we got there with 0 steps, and while Q combo steps equals Q dot pop left. If, okay, so if the combo is equal to our target, we'll return the steps it took us to get there. So one check is done, and the other one is check if it's in dead ends. So this is to avoid the time limit exceeded problem issue, because if we add multiple combos that we have already seen before, we're just repeating work and we will run out of time or hit the time limit exceeded issue. So let's generate the children's. So children equals helper combo. This is where our helper function comes in. So define helper, and this helper function is going to take a combo and it's going to return a list of strings, and this function will basically generate all possible paths from a combo for combo, new combo in children. For each new combo in the children that we get from helper function, if new combo in dead ends. So if it's not in dead ends, then let's add it to dead ends. So we just add combo or new combo in Q dot append. We'll also add it to the queue because we haven't seen it before, so we need to check it in the queue. Q dot append new combo steps +1. And then if the queue ends without finding an answer, we return -1. And let's crack this helper function. Okay, so our answer is going to be a list, and we're going to return answer at the end, and then for I in range 4. So there are 4 characters in every combo. So for every character in the combo, we're going to go up and down. So we're going to go up and down once for every combo, for every character in the combo. So new digit is going to be, it's going to be combo I, right? So it's going to be the I to digit, and we're going to convert it into an integer, and then we're going to add 1, and then we're going to mod 10 to remove the first significant number, because our combo cannot be 2 digits, it can only be 1. So we're going to mod 10 to remove any extra significant digit and then we will convert it back into a string. So that is our new digit. Our new digit is the ith digit plus 1 and then modded 10 and then convert it back into a string, right? So then our answer let's add it to our children list. So it's going to be new digit plus the everything after the new digit. So it's just going to be combo new digit plus 1. So everything after new digit and everything before new digit. So it's just going to be combo new digit. So everything up to new digit, not inclusive. You only got to do it for negative. And for negative, we subtract 1, right? But there's a little issue here because we can't really mod 10 on a negative number if our character does go negative. So after we subtract 1, we're going to add 10 to give it a significant digit if it does have a significant digit. So it will make sure that our answer will never go negative before we mod it. So we're going to subtract 1, right, to get where we need to go, and then we're going to add 10 to give it a significant digit so we don't have to work with a negative number here. So this just simplifies to plus 9, and then we will mod 10 to get the significant digit that we want. And then we're going to also add this one to the answer list, and then we return the answer, and then our main function will handle all those children into the queue. And I believe that is the solution. Ooh, slice indices must be integers. Oh, sorry, it's not new digit, it's I. Okay, and then submit, fingers crossed. And there we have it, folks. Thank you for watching. This has been the daily LeetCode challenge. See you in the next one. Peace out.